Hi folks, we are here at MetalQuest in Hebron, Nebraska. This is the coolest shop I've ever seen in my life. I got to meet Scott on the NTMA trip earlier this year, and he invited us out to see just what they have done with a flock of Fanuc robots. What I love is it's not just the machining, it's not just the technology, it's tying it all together, the software, the systems, the processes, the place, and the culture, and you're gonna be blown away. Tell me where we are.
Okay, so we're using the robot right here. This is an Akuma Multis, which is a hybrid mill-lathe combination. It's got the tool changing head of like a horizontal vertical machining center where it's on a lathe platform. And this part right here is a butterfly valve disc, and this is the casting. It looks like a relatively simple part to make, but what's difficult is you've got two cylinders that have to be concentric with each other, and you've got a spherical radius that has to have a center line that intersects those two cylinders.
Sure.
So from a multi-operation standpoint, it makes it difficult to refixture and pick up in different ways. We're using the Multis right here to do all these operations in one work holding. We're locating off of these lobes right here to get the part centered up, using the tailstock to put a consistent amount of pressure on it, using the actual milling heads to do the shell milling, the drilling, and the reaming operations, plus we're doing broaching on top of that. And then we're using the lathe operations to do the spherical radius.
Amazing. Amazing,
You know,
all in one op.
Absolutely. This was the simplest way we could find how to do it. And from an efficiency standpoint, these are the type of parts that often get sent overseas. A lot of times lower margins, so we have to work intelligent. We have to figure out the most efficient, the best ways to do it. As you can see, the robot right here, its main job is to load and unload this. You know, the operator makes sure and pays attention to tool life, using tool life management. He's doing the gauging on the parts and stuff like that. But the robot literally is able to achieve over a 90% utilization on these machine tools and uptime.
Amazing.
By always
Unheard
just
of.
being here.
Yeah.
You know, it's like a human being might be able to load a machine faster than a robot, but the consistency of the robot always makes up for that.
Yeah.
And a lot of people talk about robots taking people's jobs. You know, we're going to have a lot of robots that you're going to see today. You know, we've never laid a person off because of a robot. You know, we've just repurposed them. And a lot of times what the robots are doing are the carpal tunnel type repetitive jobs that a lot of people don't want to do. Yeah. And I guess our people take pride in the robots just because of that.
I really hope we get to hear more of Scott's story today. He started this company in 1996.
1996, January of 96.
So we're now 23 years later.
Yep.
And it's what an awesome entrepreneurial story. One of the reasons I came out here without hesitation to visit him in Nebraska was his sort of entrepreneurial and business mindset. And in case in point, when I showed up this morning, one of the first things that we were talking about was ever since the day one of their first machine tool, they have actively used tool life management, tracking that data, obsessing over, understanding how to fit that in, and now you see it with automation. I've already learned so much about these robots. This is RB1, their first robot. We'll see more throughout the tour of their naming convention, how they're picking this parts up. They're using vision to pick and then place. When the robot is loading it into this custom fixture that they made, the robot goes into a kind of a slack mode where the robot's able to accept a little bit of movement left to right. That way it's not fighting against the fixture and the clamping when it goes in on a really cool fixture that's able to support the part with the tailstock, but also give peripheral access to it. There you're seeing it come in with the rotary broaching operation where they're able to hold a really tight tolerance and again, finish this all off in one operation. And these carts bolt onto the machine tool for location and rigidity. And then they got these floor clamps. So when you want to work on the machine or get this out of the way, a matter of seconds and wheel this thing out of the way.
Yep, absolutely.
Awesome.
The Stako clamps on a receiver that's bolted to the floor. Yeah. You pop your floor jacks, you roll it out of the way. You have Ethernet, you have air, and you have electricity. So basically those three connections, this thing can be out of the way. You can set the machine up for a different job, or you can be loading it, you know, setting up a different part in this particular robot.
Amazing.
Absolutely. As you can see, we've got 4 Multises here. We've got 3 robots, basically all very much alike, all running different parts. This one right here is running a higher volume, so that you can see there's more parts on the tray right there, but still all very similar concepts. I showed a rough part before. You see the broach right there?
Yeah, beautiful.
Spherical radius.
Spin on raise. So we'll try to take a look at an assembled butterfly valve later, but that butterfly valve can open and close inside of a gasketed ring, which can hold up to multiple hundreds of pounds of PSI pressure when they do their safety checks or pressure checks, which is really impressive. Like the tolerances really matter.
Absolutely.
Yeah, this is impressive. You know, where the rubber meets the road in terms of how they start tracking all of the data behind the physical manufacturing element of this.
So when we place a purchase order, we start to track the raw material. When it comes in the door, every bundle, box, however the container comes in, it gets a tag. We have 2 tags that have the same information on it. That way, one tag is always with the material, so it's traced the entire time.
Yep.
It's just a QR code, a 2D code that we use. And from that point forward, as the material flows through the shop, as it becomes a part until it's a finished part, it's going to have tags attached to it. If you're my customer and gave me a packing list number, I could tell you everything you want to know about that part, from what machine it was on, who inspected it.
Yeah, the coolant concentration that day. Yeah,
Yeah.
It's amazing.
Exactly.
I love that.
Yep.
Yeah. So you guys stock a fair amount of raw material, but also process through this, or is this sort of long-term storage?
This is fairly short-term storage. I mean, this just came in, hasn't got back to the lathe area yet. Most of our bar stock's back in the lathe area. Everything else up front here, for the most part, in these is all castings.
Got it.
And then we have finished components either getting ready to go out to the truck or should be fairly soon right down there on the end.
Got it. Cool. Cutting the rings here.
Yep.
So these will go into this cell.
I think that's what
Twin spindle lathe that has its own built-in automation. You can see how many parts you can store here. Relatively simple. It just lifts it up until it hits that proc sensor. To know where the height is, comes in, picks up the next part. Amazing. And then it's able to move it over here to do the op2 work. Demagnetizing the part, drops it onto a
pin stamper. It's Ellis's pin stamper.
pin stamper.
So that part gets cut into 12 different pieces, and each individual little piece, when it's done, we'll be slitting in between the text.
Yeah.
It's a lot easier to pin stamp the entire ring than it is to pin stamp all the little pieces after the fact.
Right. 2 separate controls. They share the same screen, but you've got a cycle start button here for the left side and over here for the right side.
In terms of tool life management, that's our screen right there. You can see the remaining percentage on each individual tool right there. So you can see that one right there has only got 5 parts left, and it's going to need to be changed out.
So how do you figure out where the knots between the stamping is later?
Our fixture basically,
clock it.
we just clock it.
Yeah.
It needs to be centered, but it's not imperative that it's within 5 hours, something like that.
Got it.
I think
Whole row of Okuma horizontals. So what kind of work do you guys do on these?
cast iron, ductile iron, and gray cast iron are bread and butter in terms of the milling department as a whole. A lot of hydraulic type components, a lot of ag and commercial hydraulic castings, valve blocks, different things like that. We also do some work for the oil field, different smaller castings, more consumable type items for the oil field. The butterfly valve disc that you saw, we also make the bodies and stuff in these horizontal machining centers as well. So this would be an example of a butterfly valve body right here.
So the thing we just saw in the mold just sits inside of here.
Exactly, that was the disc that goes on the inside.
Yep.
The vast majority of these are ductile cast iron. We also make them out of aluminum. We've also made them out of stainless steel as well. We go from a 2-inch flow to a 12-inch flow in our horizontal machining centers.
Flow is the diameter?
I'm sorry. Basically, the seat goes inside this, and that would be the inside diameter of the seat. So like the outside diameter of the disc, like a 4-inch outside diameter would be like a 4-inch flow. So this right here is a 4-inch body. So we go all the way to a 12-inch flow body, which is about a 14-inch bore.
Wow.
For a big flow line.
Wow. What stuff flows through that?
Everything from wet concrete, dry concrete, fracking fluids, sewage, milk, cheese.
Oh, literally everything.
Literally everything. Air, a butterfly.
On the way in, on the way out.
Exactly. A butterfly valve is a very simple type concept, but it's so important to use in most flow lines. It's a cost-effective valve, usually a lower pressure valve, under 500 psi, for instance. Yeah. But whenever you need to valve or throttle something, it's a good idea. It's a good solution.
Yeah, got it. So these come in as castings as well?
They come in as castings. So we've got a lot of different varieties of the actual shapes too.
I like it though. At every machining center, they've got these downdraft tables, some really cool ergonomic tools to just make a quality of life. And for a cast iron shop, you guys keep it really clean.
What? No.
Oh, it's when you step on it that it turns on? Oh, I love it. It's got a mat. I
So
love
it's
it.
a pressure mat, and it's got a delay relay to make sure it doesn't cycle on and off all the time.
Yeah, debounce it. That's cool.
But yeah, here's the example of the
Okay.
casting right here before it's machined.
Yep.
So as you can see, we need to machine both faces, both the front and the back face, which we're doing in one work holding. Machine the bore, drill your holes right here, drill dowel holes, ream them, do a flange bolt pattern right there.
All in one.
All in one operation. We work as hard as we can to make sure that we do not have op 10s and op 20s.
Yeah.
We want to do it in one work holding, one fixturing, and we try and position the part in whatever way and use whatever tools we can use to make that happen.
Oh, that's that deburring tool.
That's the deburring tool. Yeah, we're deburring that hole
That's
right there.
cool.
So you can see basically it's feeding in slowly and it's hitting the leading edge of that hole.
And
And
it
then it's
ramp
feeding
rapids.
out, getting both sides of the fixture.
That's awesome.
This goes back to the variable program that I was talking about. You know, when you see this program scroll through, you're obviously going to see some coordinates, but there's a whole bunch of math that gets done within this program. For instance, at the big picture, the majority of this program actually is ran off of true print dimensions. You know, the min file that you see on these is actually like BC is equal to 1.5, we'll say. You know, and it's actually a true dimension off the print. Because these are a family of parts, you know, we can do that. And then mathematically, the machine figures out what tools it needs to run and actually feels a lot of the tool paths. It figures those out electronically.
Huh, that's cool.
You know, because we have so many different styles and different part numbers of this, we wanted to try and make it as easy as we could. You know, we get different variations from time to time.
Yeah.
It makes setting them up super easy.
Yeah, fewer programs, fewer.
Absolutely.
Yeah, I like
Absolutely.
that. Cool.
All these horizontals are running, I guess, similar type parts. Like I said, a lot of cast iron. You know, we're running, you know, steel on a few of them, but for the most part, valve bodies, valve blocks, you know, oil field type cast iron components, etc.
Yeah.
We have 6 400 millimeter horizontals, and we have 1 600 millimeter horizontal.
Okay.
Hydraulic part, there's a lot of grooves.
Yeah.
We have surface finish issues and chip issues we want to be able to see. So you have the old school way with the dentist mirror to get in there and look. Obviously, it works, but not very convenient.
No way.
So what you do, this is called a sight pipe. So you drop this in here, you're getting a 360 degree view at a 90 degree angle.
Stop.
So
And then you can pull that out and you can see all the grooves.
like half of a periscope is a good way of putting it.
Oh
Like
my
half
God.
a circular
Do you just make
periscope.
this?
And
Yeah.
actually,
Yeah,
Scott's
we've
son
made them before.
one.
Yeah.
But yeah, normally we just buy them.
Your view is getting kicked 90 degrees.
That's
So that allows you to
amazing.
see the outer surface finishes and stuff like that, and all the different features we're putting in, which is very difficult to see with a 10 light in a mirror like Volk was showing.
That is really cool. I love this too. They've got a computer-controlled torque wrench on a stabilizer, you know, tool holder, and it knows the number of times it's tightened and loosened. So it literally it knows that there's 7 or 8 or 10 bolts that need to be tightened. You can control the order or the sequence. They can all go to a certain foot-pound and then do an additional. Awesome.
And one overlooked aspect of any kind of manual fixturing is consistency on tightening.
Yeah.
And I think everybody's been burned on that. So almost every manual fixture we have in this building, we use torque wrenches on it. Even though if you might not need to do it, it just makes sure that one operator is always tightening it with the same level of consistency as the next operator. And then when you have more complex fixtures like this, in this instance, this DC torque wrench, it's tightening everything down at one torque and then coming right back and tightening everything down at a second torque, just because we need to make sure everything comes snug, like consistently.
And why I like Scott so much is we're telling you about this, and then he's like, "Oh yeah, and we got that off eBay."
Yeah, absolutely. eBay is a wonderful buying tool. A bargain's not a bargain if you can't use it, but so often, you know, industrial type items like this, you know, there's not a huge market on eBay that buys them. So a lot of the technology you see on the shop floor has its roots tied to eBay. If nothing else, we'll buy one off eBay just to test it and say, hey, is this a concept that we can implement? And it's like, it's a good way of learning a lot of different things.
This tour has been like full of tips. The other thing, why dunk your parts? No, bring the water up to them.
Yeah, usually we'll load this full, and it's like, you know, you can walk away from it or whatever. It's got an overflow, so it's not going to run over. The level comes up, it submerges everything. You flip the switch back, it drains everything.
Don't have to be banging parts into each other.
Absolutely. And these parts are a little heavier, and they're hard to put in a bucket to dip or anything like that.
You guys made this?
Absolutely.
Yeah.
I think we got, what, 2 or 3 of them?
Not only did you make it, but it's DT1, and you need to go look up the maintenance system in the
Absolutely.
in the system. I love that.
So this was the system we came up with because we were spending a lot of time hauling water. And that sounds dumb, but every shop, you know, some people have water trucks, some people have really long hoses. And invariably, you have spills, you have floods and everything. So what we figured out, it's like, if we can just move the water to the machines in an intelligent manner, let's say you're running an 8% concentration rate of coolant. If you can move the water to the machine, you've done 92% of the work. So what we did is we basically came up with individual screens. So these are the different machines that are on this particular panel right here. So like, I'm not gonna dump a lot of water in, but let's say I want 0.2 gallon right here in this machine, okay? So you can see right there, there's 0.2. On this machine right there, I'll just go 0.4, okay? All right, I'm gonna go on this machine right here, I'm gonna go 0.35, like that, okay? So I've got all those, and then I can walk away, I just hit cycle start. And what it's gonna do is it's gonna go through and it's gonna fire valves individually.
I love it.
So you can see the
Yep.
that valve right there was just thrown. So as you can see, it's metering water out to each individual machine.
Next one now. Yeah, so they have the PLCs also bought off eBay, controlling 24 volt solenoids on a water system.
And see, we have a barrel that's got a very accurate, you know, basically when you crank the handle one direction, it fills the sight glass. You crank the handle the other direction and it meters it out. In terms of our coolant concentration app, we'll know exactly how many ounces of raw concentrate coolant to put into our machines with this amount of water. It knows the starting refractometer rate. It knows what the target needs to be. So therefore you put in that number of ounces, which is then recorded in the background. So we know the true amount of coolant concentrate that each individual machine tool in this building uses.
You were smart enough when you built the building to bury tubing so you can run PEX lines there, and then you just have your PEX lines that run up there.
And all around. The majority of our shop is gridded out. You know, this one just didn't work. Yeah. So like one of the conduit lines would come right here and power us for the other one. So there's a 20 by 25 foot grid through this. Okay. And that keeps a lot, I mean, you don't see any like major hanging wires. Yeah. These are close to our panels, so we just ran them overhead because it was easy to do. But the majority of our power, our electricity, power and electricity, vacuum, air, and water, Ethernet, they all come through the floor. Cool. This is our 600 millimeter horizontal, 50-some thousand pounds.
Wow.
We use air skates to move all of our machines.
Oh, really?
I don't know if you've ever seen those
before.
Yeah,
it's amazing.
You see a machine this big and it's really hard to imagine. You know, you have one person on each corner and that's literally all it takes to move a machine like that. Amazing. And then we've got one guy that runs a regulator panel. So there's a pad on each corner and he just dials in whatever pressure he needs to make sure that machine sets flat and consistent. Everybody wants to help push it, but obviously with momentum, stopping it's harder than starting it.
Yeah, they were talking about how important it is to finish a part in one setup, and this kind of tool is an example of that. First of all, it's really heavy because it's a 50 shaper, but take a look at that tool. Sole purpose is to do backside, not chamfering, actual proper machining on the part, so you can hit the backside of those circular flanges from one setup. Super
now imagine
cool.
As a shell mill, like a backward shell mill. This is a 10-station pallet pool right here. We use a lot of our lower volume type stuff. You know, we can set each fixture up and, you know, we might just cycle it a couple times a day.
Got it.
You can see there's a set of castings right there that are queued up, getting ready to go on the machine. There's another one right there fixtured up. You know, it's probably in queue right now. One thing we take pride in that we're trying to do a lot more of, you know, is a concept called outsource vertical integration. You know, that might sound like a contradiction of itself. We manage the product line literally start to finish. We take care of all the raw, all of the sourcing at the very first levels of it. We take care of all the coating, heat treating, specialty type applications, anything even from NDT on that has to be done. So in the case of these parts right here, we're literally putting them in the box. You know, the customer doesn't
ship it. It's amazing.
Exactly.
Yeah. This is awesome. We've seen these before. If you're not familiar with them, you can punch in a job number or your employee number. And you know, you can look up an insert or a tool. It'll pop open the drawer or tell you what drawer it is. A drawer like this may have 15 dividers, but it will only open the drawer up to the divider you need. So you know that the part you're looking for is in that one that's closest to this wall frame. Here is the coolest thing that I learned today. You can leverage these with existing toolboxes. One of those genius moments that you never thought of. They've got a bunch of dumb toolboxes, the Kennedy styles, locker cabinets, etc. So let's say you need something like a special 5-gallon bucket or gallon bucket of a special type of coolant. Well, there's no reason to spend a bunch of money to store that in a really expensive system. So you punch it into this system, it opens drawer 7, bin 12, and in that is the key.
So an example, like we have a 55-gallon drum of hydraulic oil.
Yeah.
We have a special cap that we made with a padlock on top of that.
Amazing.
You know, this toolbox unit keeps track of that. You
Yeah.
withdraw the key, you go take that padlock, you unlock it, then you get to the bung, you know, then you put that drum in service. Now you have the reorder list that shows
Yeah.
that drum was withdrawn.
Everything upstairs and behind that gate there is all of our cardboard.
Yeah.
And that's all in the toolbox right now. Up on the top of the crib, we have a bunch of maintenance items. So when a machine goes down, the maintenance guys can go to the toolbox and get
Yeah.
a new belt or pulley or whatever, take it out of the toolbox
Yeah.
and go fix the machine.
And it has very little to do with physical security. I like worrying about theft. It has everything to do with making sure you don't run out of that fluid. Making sure you know that you grab this tool or part or material to top up or fix this sort of a system. So it's a trade-off for sure, but I love it.
It's a
Absolutely
huge
love
organizational method. These are supply point cabinets, and we've developed a really good relationship with these guys, and we're doing some cool stuff, you know, just building upon what they do and just trying to optimize it for our environment.
One of the unique things that we're doing that's different than what you normally do at the toolbox is normally you put your job and your work center and everything in, and then you have a list of everything. We have this actually talking to our setup sheets. So when I pick a job and I pick the machine that I'm on, this only shows me the things that are on my setup sheet. You can see
awesome.
that's a really short list. So the operator
Yeah,
only
right.
has the tools that they're available for that
Right,
job.
right. But everything from a hex key to an actual reamer.
Yep.
That's awesome.
Yeah, shims, screws, everything are all right there.
You get a picture of the insert.
And then it's down the light, the drawer lit up
Okay,
right
so
down
the
here.
drawer's lighting up, and then it pulls open only to the last spot, so
That's
you
the
know
one.
that's what you need. I love it. That's awesome.
What we like about these is these are totally modular. You can see lots of different styles of drawers in these cabinets. You can add on multiple cabinets. You can put in what actually like cabinet doors themselves, all the way to high density type.
Yeah, we got like bigger cabinets here. And then the new model, the Roto, this is really awesome. You can kind of see in here,
Oh, yes.
there's like 460, I think 460 something individual spots. And you can actually take the dividers out and open that up a little bit if you want, but same concept, you pick it, this will roll around, and then whichever drawer lights
Yeah.
up and you slide it open, reach in there and grab stuff out.
I love it.
So we found that for most inserts, it's a lot better to keep the inserts in the original packaging
Yes.
versus having them in there because they'll slide around and kind of start chipping out. So we went to this unit so we can just put the packages right in there and take her out of the package.
Yeah. You're actually seeing us mid-upgrade right now. We're upgrading from those larger frames right there to this unit right here, which just came in a couple weeks ago. It's got a newer backplane, newer hardware, newer computer system, and as you can see, it's a lot smaller because we're taking a lot of the bigger items out of those drawers and we're putting them in this
Yeah,
Roto unit.
super efficient.
And we're reusing most of our drawers from that. We'll plug right into
And
here.
there's so much more density here that we're actually losing 2 bays
That's awesome.
because of all the extra room we can put in there.
I like that.
Yeah.
Okay. Tool room. Rethinking about how we grow, how we handle efficiency, but then also how we run our 5-axis. To put it simply, it's worth it to invest in additional holders that leave tools set up. So I always have a holder that has a 1/4-20 tap as well as the drill for it, because then I don't have to look for the holder, I don't have to look for the tool, I don't have to look for that collet. It's all set up, it's all ready to go. And really cool to see your tool room and how you guys think, leaving some stuff in broken down, but then also some stuff set up here.
This is our main tool crib area right here. We have a tool crib attendant, and basically his responsibility, he goes around the shop, and we have designated areas where both new or sharp tools and used or dull tools are kept. He'll run that route, he'll pick up all the dull tools, he'll immediately throw them in the ultrasonic cleaner, get everything cleaned up, flip the insert, change the tool out, etc. Bring it to our presetter right here, do a preset, possibly balance, possibly heat shrink, whatever needs to be done. We're complete climate controlled.
Cool.
But we've got that, and we've got a fan basically that keeps a positive filtered air, running throughout here. But we use a lot of heat shrink, a lot of multi-step,
Look at
form
some of
type
these,
tools.
Some of these drills. Look at that. Chamfer, drill, additional drills toward the tip. That's
When you're
crazy.
doing more production type oriented work, you want to try and get as much done as you possibly can in one particular operation, because we're running higher volumes. So yes, where you might think an insert drill would hit, a single diameter, here as you can see, there's actual multiple features, even all the way to chamfers. You see a chamfers being put on
it's
right
incredible.
here.
Yeah, I love it.
It's like a multi-step roughing tool. So yeah, we have a lot of different examples of stuff like that. Boring heads, we get into some more complex boring heads right here. In this instance right here, this is actually a roughing and a finishing combination head to where you've got 2 roughing inserts and then you've got a finishing insert that's trailing.
Yeah.
So basically when you punch this in one time, it goes in, roughs and finishes it.
That's amazing.
And that's a balancing hole right there for your balancer.
So you got your
Got
tool
it.
balance,
So yeah, that balancer right there told us this pocket right there
Yeah.
to take out to make sure that this thing is not damaging your spindle when it's running.
You can actually put a holder, a smaller holder in this machine, can spin it up to the RPMs needed, and then it can give you micro adjustments in the form of either set screws or pins or collars or rings that can go in here or down there, and it can literally perfect your balance, which can help for tolerances, for tool life, for finishes, everything.
Absolutely.
Spindle bearings.
So this balancer right here, they have different set screws available. This is a Heimer holder and it's a Heimer balancer. So yes, you can put different set screws. So you might put like one weight of set screw right here and a totally different weight of set screw right there to end up with an average balance point, somewhere in there.
But the machine tells you.
The machine tells you exactly what
right.
to do.
That's awesome.
Correct.
Oh, this is cool too. We just saw this on the horizontal, but it was really tough to see. So this is one of the Cogsdill, I think it's Cogsdill deburring tools. It can deburr on that top edge, if you want to point to that top edge, Scott, and then it rapids through the hole and is able to use the back edge to deburr, and it doesn't cause a problem or mark on the part as it rapids through.
Right. You can see how it's kind of radiused right there.
Yeah.
And it's actually designed basically to not cut.
Oh yeah, it looks like it's polished right
Yeah,
there.
exactly.
Yeah, look at
Yeah,
that.
so then it just string
Goes
loads.
right through.
As soon as you break the thing back, it starts running on that area right there. So yeah, it doesn't leave a drag out mark that you might expect.
Right. This is cool.
Something that we're just huge on right here is trying to get as much done in one operation as we can. This is a big Kaiser right angle drive. We use several of these things in several processes. More so like, for instance, if you've got a part that has just a single feature, like in a horizontal, and it might come in from the top, it's like you've got a lot of these things fixtured up. To us, it's more important to get it done in one operation than it is to take it out and have an op 20 or an op 30 or whatever the case. So we'll tool change these things in, come in and just basically
drill,
do that
mill,
operation.
yeah.
Exactly.
That can get tool changed.
Absolutely. It tool changes all the time. So you can see right here this orientation pin. You can see this whole thing is locked in. As soon as the tool changes, there's a special receiver, and this is kind of hard to push in by hand. There's a special receiver in there that basically collapses this, so that way it disengages this cog. That way this then will float. So you'll start rotating that, which transfers right into here.
Yeah. So you still get, you're still getting your actual motion from the spindle rotation.
Absolutely.
Yeah.
So this entire collar right here is designed to be adjusted. So you adjust this pin for wherever the female version of that is on your machine tool. And then you get that dialed in. There's a band right here to indicate, to make sure, you don't have to have this 90 degrees. You could actually do an operation like that if you wanted to.
Sure.
It's very versatile like that.
Wow. So this is more for your Okuma horizontals we just saw.
Yes, correct. That's where we run these things. You can run them in a vertical if you need to or want to or whatever, but yeah, we put them in the horizontals. And it's for off-axis, or I guess, stuff that we can't get basically by spinning your B axis.
We're running one on the bottom and one on the top of the part, so we actually have 2 of them.
Oh, really?
Yeah.
Yeah.
On each machine that's running.
That's cool.
That,
Yeah, you kind of see like this retracts right there.
Yep,
And then
yep. Yeah.
Exactly.
Work on that grip strength, Scott.
Yeah, exactly.
Come on. We love our shrink fit. This is way nicer because it's got the instant cool. So, I mean, you could swap a tool out in seconds.
Well,
It's
you
ready
can
to
heat
go.
it up in seconds. It takes a little while to cool off. You can see there's a chiller underneath right here, and you got these cooling jackets.
Okay.
The biggest thing with a heat shrink you never, ever want to do is double heat something. Like if you hit your button and you go through the heat cycle, if you can't pull your tool out immediately, the last thing you do is hit the button again, because then you get it too hot and you exceed basically the design requirements of the steel.
Got it.
So you want to make sure and get it back to ambient. You can change your heat setting a little bit sometimes to try and help it out, but you can't double heat it. But yeah, these cooling jackets right here, once you go through it, there's an antifreeze in there that keeps everything cool.
Oh, cool.
The nice thing about those jackets is it provides uniform cooling around the shank.
Yeah.
Like some people throw fans on, and what happens is, it's kind of weird, but the tool actually will start to drift as you start cooling on one side more than the other. So we do use a lot of heat shrink in this building, and we really do like it. Rigidity concentricities are phenomenal. Runouts. Occasionally, once in a while, you run into a shank that's made wrong. You need an H6 shank, H6 tolerance shank, and we've had a couple issues with that, but that's actually been a fault of the tool in almost all cases.
So this is our butterfly valve assembly line. So we're starting at this end of the line, grabbing a body that's been painted, seat, a disc, starting to bring that seat and the disc together. moving it around the line into a press. So right there, they're pressing the stem into the assembly. There's your palm
that's
nailer
fast.
in action.
That's awesome.
So yeah,
That beats
putting in
hammering on it.
a roll pin. Yeah, that beats the heck out of a hammer.
Oh yeah.
The main test we do is with the valve closed. We can also do a shell test. A shell test then where we open the valve.
Oh, cool. Okay.
And to make sure that there's sealing on both sides.
Yeah.
From there, dropping on some final hardware, nuts and bolts, banded if it needs to be CE banded.
Oh, that's amazing.
That's our
Cool.
custom built
Yeah.
banding. We buy these pre-cut and then we run them through pin stamps, put all the proper information, final touches, and into the box, and away we go.
Yeah. On the machining side, what's a normal and what's a high volume part for you, monthly or annual?
A high volume one for us, 40, 50,000
A year?
in the segment sell. In a month.
A month.
In a
40,000
month.
parts a month.
Yes.
Wow.
So, some spools that we haven't seen yet, 20, 30,000 a month,
Wow.
depending on. So,
Wow.
machining center stuff more like a typical run's more in the 500 to 2,000 range, probably.
Okay. I didn't expect to see this.
Yeah.
Manual mills.
Yeah, there's a time and a place when it's
Okay.
just as easy to come over here and knock it out,
Okay.
So,
I don't think I've ever seen 3 orange vices on manual machines before. This is a really nice setup. It's
Yeah.
a nice tool room or general use setup here. Oh, and then
Yeah.
there's the M560V. Oh, I love that. That's awesome.
yeah,
So it's just tool room use or one-off
absolutely,
stuff.
yep. Yep. Haas TL2 lathe
Yep.
here. This would be our only 2-axis lathe in the building. We haven't had a
Good job.
2-axis lathe for quite a while.
Yeah, right. Walk me through the lathe department.
All right. So we have 9 LT machines, which are 8 of the 9 are a twin turret, twin spindle live tool.
Okay.
The 9th one is a triple turret.
Oh my God.
So
It stuff gives me nightmares.
yeah, they're actually a lot easier to program than you think because
Oh, yeah?
it's really like 3 different
Okay.
lathes. So
Got it.
yeah,
But still, 3 turrets just
but
seems
still there's a lot going
incredible.
on.
Yeah, right.
yeah, it's a little intimidating.
Yeah.
That's just kind of the mindset that we've always had in this company. We're just approach projects a little bit differently than
Yeah.
a lot of other people do.
Which is cool because this is kind of an awkwardly open spot because
Yeah.
this is where the index is going.
Yeah, so we got an index, MS40-8 is going to be sitting right here in December, mid-December is when it's
Amazing.
coming in. Yeah,
That's a cool
really
machine.
excited about that.
8 simultaneous spindles with up to 16 tools in the cut
Right.
at the same time.
Yep,
is that
yep,
correct
yep.
statement? Yeah.
That's correct. And then we have 2 pickoff spindles, so you can do back work on too.
You were saying a part that is almost 2 minutes is going to go down to sub
Yeah,
20
like
seconds?
a minute 50 cycle time. It's going to go to around 15 seconds.
Wow.
The cool thing is not only is it going to open up the capacity just on that machine, we can do parts that fast, but now we have capacity on other lathes.
Yeah, sure.
So we didn't do any type of building expansion. You bring one machine in, going in a spot, that, and this had a different machine here obviously, but a spot we had open, we can open up capacity on a couple other lathes, plus have additional capacity on the index.
Yeah.
So it just grew the whole business.
So that's what you're going to do. The index is going to run a part you guys already made.
Yeah, there's 5 different part numbers we're already making. We're moving them to that, taking them off of the current lathes, and yeah, it'll be a really good
Cool.
thing for us.
Cool.
Yep. Almost all of the lathes have bar feeders, 12-foot bar feeders on them. We have a couple chucker machines, but by and large, everything's got a 12-foot bar feeder.
So that's a regular twin turret.
Yeah,
twin
this
spindle.
is a twin turret, twin
Yeah.
spindle, the LT200s, which we have 7 LT200s. We have one LT10, which is older, like the older version of the
Okay.
LT200. And then we have the LT300.
That's the big boy.
Yeah.
Okay.
Yeah, we have 3 of those. But
What-
the one's a triple turret.
What? Tell me about MS36.
Okay, so a lot of our lathes, we have part ejector systems on it. So
Yeah.
MS36 goes along with MS17 here. When the parts catcher drops, there's a door inside here.
Okay. Oh, so you did. This is not Okuma. This is
No,
you.
we built this.
Oh.
Yeah, we built all this.
That's awesome.
Yeah, so this door will fall down.
Okay.
Parts catcher comes up, it drops it down on the rail here, and there's a rodless cylinder inside here, but it pushes this thing right. So this whole truck,
That truck moves forward.
along.
Okay, so it's not a conveyor.
Yeah, so instead of having the rod like here that pushes the whole thing,
Yeah.
it just goes underneath and
Cool.
moves that
Sure.
along.
Like a, almost. Okay. Yeah. Yeah.
Yep. Falls out here. This actually when this is getting dumped, it pushes the part out of the way. So when this part comes rolling out, it's already pushed the parts out of the way here.
Okay. So the parts don't hit each other.
Right,
All right,
exactly.
that's what we're thinking about this now with our robot. How do you unload it? Where do you put the parts?
Yeah.
You don't want to be dropping steel on steel.
Yep. So then
Okay.
the other thing, most of these machines are, you got 1 person to 2 or 3 machines. So this machine has an insert change, but then I get an alarm on that machine over there. I don't want get my parts mixed up. So what I do is I take one of these dividers slide my parts over,
Yes.
put the divider in, and now when I go take care of that machine over there, anything that falls here is after the insert
Yep.
change. So if I did have a problem, it's only going to be
Segregated.
with those parts right there.
Right.
Yep.
I love it. Yeah. What an awesome, like, it's the beauty is the simplicity, not the complexity of
Right.
it. It's quite simple. There's nothing complicated about
No,
this
it's
hopper or
very
that.
basic, yeah.
I love it. You see that? Yes, look at it.
Yeah, there we go.
So does an M code trigger that?
It's tied into the parts catcher advance.
It knew
It's
that.
in the PLC.
Yeah.
Yeah.
There's a
Yeah.
sensor.
Yep,
Yeah.
exactly. So we watch when the advance sensor goes low that we've advanced, the whole cycle starts.
Yeah. Awesome.
The last part we've checked, we're always going to set it right here.
Okay.
And so now, same concept as you described before. If I walk away, I can put that divider in.
Yeah.
When I've pushed all my parts down that from this inspection, everything's good. Now I drop the divider in.
Yes.
If I leave for 2 hours for lunch, whatever, we run lights out,
Yeah.
4 or 5 hours. We come in the morning, we know exactly this is the state
Yes.
of the last part.
Got it.
If this one, you find a problem feature over there, if this one was good, again, it's segregated.
between
You
there.
now know
Sure.
what you have to look through.
But if that one was obviously good, and then the last one that came off was good, then you should, in theory, be good on everything in between.
Yeah, we'll do a spot
spot
check of a
check,
number
yeah.
of parts depending on the lot, but yeah.
Cool. I love these. This is like a captive system, but from Kennametal. That's
Yeah.
what you're saying. It's like
Yeah,
it looks like
AM40.
It's
HSK.
very similar to HSK. It's a little bit different.
Okay.
It's their own proprietary design.
Repeats though, and it's a single wrench that just loosens. And this
Yeah.
has orientation though. It has to.
Yeah.
Yeah. Okay.
Yep.
Cool. God, this is amazing.
Yeah, cylindrical
Holy cow.
12-meter rail gantry system on our robot here. We got a 50 kg Fanuc robot.
Wow. 100 and some pounds.
Yeah,
Holy
110-ish.
cow.
So we're using vision here. So right now we're detecting, taking a picture of that cardboard box,
Oh
dropping
my
a finished
God.
component in there.
Okay, so it picks up a raw material, moves it into a twin turret lathe, and then it also takes them down to the other machine, which is a grinder.
The Kuma cylindrical grinder.
Okay.
Yep. So some of the tolerancing on the OD of this part, the finish requirements, you could maybe turn it and get 1 or 2 parts that way, but consistently part over part, it's
Gotta
something
grind.
that needs to be ground. So, yep. So we've got obviously a long cycle time on our lathe, so we went ahead and had a robot service both machines. I'm not sure if our grinder might be shut off.
Is there
right
a
now.
way to do this other than an overhead robot? I'm trying to think.
I suppose in theory, if you could get
opposing?
everything,
Cell?
opposing machines,
Yeah.
something, but then set up any insert change, things like that. I mean, your cell goes
Got
down
it.
now if you've entered into it.
Yeah.
So that's the difficulty with that.
Could you go into work in this cage here and let the robot still take parts out and put them in the grinder?
Yeah,
Okay.
yeah, absolutely.
Stamp, too.
Got it.
Basically, anything that's being worked on, the other machines can still run. It just
Okay.
zones out that area.
Yeah.
Yeah.
And then I love the ingenuity. I mean, again, like literally state-of-the-art Fanuc automation system next to 2 Okuma machines, and then some DIY Delta woodworking lathes with Haas tailstocks to do some light polishing.
Yeah,
afterward.
we've got some pretty high-end polishing
I
that has
love
to
it.
happen on these. They weren't able to automate it.
Yeah.
So this is what it takes to get it done.
Yeah. Awesome. Oh, and
I
that's
think-
the grinder?
Yeah.
Cool.
Yeah. Killed
You don't
it,
get to
so.
see these every day, so that's what drives the rotation there. It's your spindle, basically, but then there's your giant wheel back there, which looks like it's still running.
Yeah, we're still running, ready to go there. So
Cool.
and that's a floating chuck.
Okay.
So the actual center is rigid,
No.
and the jaws float to it. So all those jaws are done for is just driving. It's your lathe dog concept.
These are done. Right.
Yeah,
Right.
So we're driving the part off of that, but the center's
So you
holding
maintain
the
off the
positions.
ID for
Yep.
concentration.
Exactly.
That is cool.
Yep.
Huh.
Marpos in-process gauging system. So we're
Okay.
measuring that part while we're grinding it.
No.
Yeah. So
Real
when the
time.
part comes in,
No.
this gauge will advance over the top of the part. While we're grinding, we're real time.
It's like a
So
real-time
that's what this
micrometer.
is.
Yep.
Oh. Now, does this talk to the control?
Yes,
Yeah.
absolutely. So
Also-
there's a cycle within the grinder.
It's like a PID loop. It just
Yeah.
like it goes until it's satisfied.
Pretty much
Exactly.
can't make a bad part.
Yep.
Yeah.
Right.
Yeah.
So I mean,
Wow.
parts apart will consistently have 50 millionths from parts apart.
So that is a contact. It's actually riding
Yeah.
the part.
It's
Okay.
real. Yep.
That is cool. They're just switching over some more coating, but this is nightmare stuff right here. 1, 2, 3 turrets, dual spindle, obviously lots of
Live
driven
tool.
tools. Oh my
Yeah.
God.
Yeah, 16 station turrets,
48 stations
Yeah.
overall.
all
Wow.
live.
And each turret could do, I guess this one really wouldn't do much on the sub for no reason to, right? But
Right, yeah.
Yeah.
So that one's slaved to the left
back.
spindle,
Yeah.
that one's slaved to the right, and then this one will go to either.
CMM's hidden everywhere.
Yeah, we've got shop floor.
5 shop floor CMMs and 1 QA CMM.
Yeah, and they've been really innovative with like quality of life, I would think of it, fixtures here. Can I step on the pedal?
Yeah.
So they've got a way to measure different parts by just adjusting. I love it. Or saving the best for last. Raw material. It goes into the twin axis Okuma lathes, and then from there on out, it never gets touched by a person. The last thing they're going to be doing in here is adding in more gauging and metrology stuff. But literally, this last robot even builds the box and stacks them into boxes that can get directly shipped to customers. Absolutely amazing.
But this entire cell is designed to run 2 different part numbers simultaneously. Today we're only running 1, but basically this could be doing the exact same thing on the second line, you know, where the RB7 would put parts on the left-hand pusher table instead of just putting them on the right-hand pusher table as we're looking at. That's how you get your part flip.
Oh, look at that.
And great.
50-second machining cycle time, and then part to part, you're probably another 17 seconds on top of that, 17, 18 for the load. Got a 2500 from last year. Everything's faster on that.
I love it.
So we've got a finished machined ring that just came down the line. We're going to do a demagnetizing operation on it because there's eddy current testing in the tubing. The tubing may or may not be magnetized when it comes through. Magnetism and automation don't play well. Don't play well together
Did you
at all.
learn that the hard way?
Yeah, we did find that out. The first heat of tubing that we ran when we set this up, no magnetism. Got everything dialed in. All of a sudden, parts are literally sticking to vertical fixtures. We're coming through, pin stamping.
You're cutting that solid ring into 3 sections.
Yeah.
5-inch carbide slitting saw that they've gotten these fixtures to cut those into the segments.
Yeah, and this is the most boring vertical machining center you're ever gonna see. Literally, we don't even tool change. 1 slitting saw.
Right.
That's all it takes.
It's like seriously tragic. This is an amazing machine, and yeah, look, nobody's home. It's totally empty.
We get somewhere around 10,000 pieces out of the blades, so redundant tooling at that point is not even really necessary.
Right.
This thing will be 20 years old, they'll have a mint tool changer in it.
Now we're going to do our deburring operation, downdraft table there. Counter rotating wheels. We've got 1 rotating clockwise, 1 counterclockwise. So as we feed that part through, we're deburring the top and the bottom edge of the part with 1 feed move. So it started out with just a single wheel.
Yeah.
This became the time constraint of our cell backing everything up. So, you know, necessity is the mother of all invention, right?
You're doing pretty good when you're deburring op as a constraint yourself.
3 hands on what you see there. Down and to the
black
left.
piece? Okay.
That's step jaws, so we can deal with 2 different diameter parts
Same
coming
end
through.
effect. Got it.
Same end effector, and then an individual one. Once we slip them into individual rings, now they're size specific.
Okay, so I think we're almost ready to pick up a hole. Right, here we go. Oh, that's good timing. Magnet dunks them into a rust preventative, holds it there to let the excess drip off, and then it's going to set them onto a rack to let even more drip off, but not obviously take up the robot's time.
This is a demo routine that we basically built
Okay.
to show people how we can build these boxes right here with a robot. So you can see it's changing hands right now.
Changing its end effector.
It's got a special hand for boxing. So you can see it folds it like a tunnel. Then drags it along, and you saw the 2 flaps fold the first time, and then the handlebar looking things fold the second flap. And when it's done, we actually make these for several customers. We'll use different boxes for each one of them just to make sure that everything stays isolated through the process.
Oh.
So we've got different stripes on our boxes.
Right.
Yeah.
That's
Different
genius.
colors on the different
Yeah.
sites on it.
I like that.
So that way everything is uniquely organized all the way at the packaging level.
But you built this system yourself. You didn't?
Every aspect of this we built ourselves.
Amazing.
You know, obviously things like the hand changer and stuff like that, the actual orange pieces, those are ATI brands. So, you know, we bought stuff that we could buy, but
Sure.
the vast majority of this, I mean, you can't order this out of a catalog.
Wait,
So-
but you also didn't hire an integrator to come design a
Correct,
turnkey
correct.
for you.
We buy our robots directly from Fanuc. We've got a wonderful relationship with them. Their sales guy treats us really well, very intelligent, and it's been a great help from a technical standpoint. Teamwork is absolutely so important with all this. There is no one person that deserves credit for this entire process. You know, usually there's about 5 separate guys that are all intertwined in a robot project. You know, you've got one guy at the top level that actually takes care of the purchasing of this different stuff, you know, that has the upper vision. You got one guy that does a lot of the flow charting and lays out what's going to happen, because the scenarios and how things operate are the most important aspect in the design phase. You got the guys that work on the CNC machines, and that's their specialty. You got the guys that work on the robots, and that's their specialty. It requires coordination, you know, and good relationships. A lot of good guys that I'm really proud of.
Yeah.
So now you're going to see it. It's going to take those, and it's going to put the last row in place. And now it needs to go get a cardboard divider. So it's going to grab a piece of cardboard just like that and come in and drop that in place so it can put the next row on top of it. And it's a layered process.
You should be proud. And hey, really want to say thanks for letting us come out here and film, and
Absolutely.
really an inspiration to see what you've done and built this up, and to be here to see where it goes.
Well, thank you very,
Awesome.
very much.
Hey, thanks, Scott.
Oh, absolutely.
Thank you, fellas. Chad. Thank you. Scott.
Thanks a lot.
Awesome. Folks, I mean, I don't even know what to say right now. Absolutely amazing. I have 1,000 questions I want to think about, but it's awesome, selfishly, awesome timing, because we have our first Fanuc robot, which we want to make a simple part. For us, high quantity is maybe 500, and they're doing 40, 50,000 a month out of these. Really, really cool. Anyways, hope you folks learned something. Hope you enjoyed. Take care. See you soon.